Hi, this is the first in a series of video that covers the topic of MRO, or Method Resolution Order. In this video, we're going to talk about MRO in single inheritance. Now, this is the logic gate inheritance that we did in a previous assignment. So hopefully you remember the detail, but as a quick review, at the bottom here, there are these AND gates, NOT OR gates, and XOR gates. They are all gates with two inputs, one output, so they all inherit from binary gate. And the NOT gate is the only unary gate that has one input and one output. Now, both of these binary gate and unary gate, they inherit from the logic gate. Now, all the classes in this inheritance hierarchy, they are single inheritance because each of them has a single parent, and all the parents also have a single parent. So all the gates again have just a single parent, so it's a single inheritance hierarchy. Now this is the code for the NOT gate, which inherits from the unary gate, which inherits from the logic gate. Now I instantiate a NOT gate here and give it a single argument, the name of the gate. Now, if you look inside NOT gate, there isn't a initializer that takes a single parameter of name, right? So then how does that work? Where does NOT gate get its initializer with a single name as a parameter from? Well, we all know the answer, and that is because when the Python interpreter, when it sees this instantiation, it first searches for the dunder init method in the NOT gate first, and it did not find it. Then it go to its parent, unary gate, and unary gate define a dunder init method that takes a name parameter. So this is what that instantiation uses. So Python has a deterministic way of finding methods in an inheritance hierarchy. And that basically is what MRO is all about. So MRO is short for Method Resolution Order, and it is when we dereference an instance of a class and call some methods or access some attributes, and the MRO is the order in which Python searches for that method or that attribute in the inheritance hierarchy of the classes. And as we just saw, it is very intrinsic to how inheritance works. Now, since we have been using inheritance a lot, we've been using MRO all this time without necessarily knowing that it is there. So now it's the time to study it because it is an important topic. So let's look at MRO in the simplest case, and that is the MRO of a class that has no parent. So in such case, we would expect that a method or an attribute is always found in the class itself. Now, is that necessarily true? Well, as it turns out, not quite. If you remember, all classes in Python actually inherit from this object class. So even a class that doesn't explicitly inherit from any other class, its method may be found in the class itself or in object, right? So one example that we run into all the time is any user-defined class can be turned into a string or can be converted to a string by calling the dunderString method, even if we don't define the dunderString method. And that is because the object, the mother of all classes in Python, has an implementation of dunderString method. Now, what about the MRO in the next simplest case? And that is, what is it in a class that has a single parent? So in the case of single inheritance. Now, in that case, then we know when we study first studied inheritance and also from experience, that what it would do is it would first search the method in the class itself. And if it finds it good, if it doesn't find it, then it will go to its parent to search for that method. And if it still doesn't find it, then it will go to the grandparents to search for the method, and so on, and until it either finds the method or that it kind of exhausts all the ancestors, even after it has reached object and still couldn't find it. In that case, then it gives up its search. So for example, for NOT gate, its MRO is, well, NOT gate itself, right? And then it goes to the unary gate, and then it goes to the logic gate. Now, even though logic gate does not explicitly inherit from any class, we know it always inherits from object, which means object is always the last one in any MRO. So let's not forget that. Now, that is the NOT gate MRO that we can derive by hand by looking at the code. We can, in fact, verify the MRO with Python because each Python class has an attribute, dunder MRO. I believe it's a class attribute, even though I didn't quite verify it. So what the dunder MRO is, it's basically a tuple of classes in its MRO. So I'm going to show you that. So here I can print the MRO for, well, logic gate, and well, you can actually also access the MRO by doing a method called .mro, or for NOT gate, I chose to use the attribute dunder MRO. So let's run that and see what we get. So for logic gate, remember it is at the top of our logic gate hierarchy. So the MRO is itself and the implicit parent object, right? Now for NOT gate, then the MRO is NOT gate, unary gate, logic gate, and finally, again, object. So that verifies the MRO that we derive by hand. So I would like you to give this a try yourself, that given this inheritance hierarchy, perhaps work out the MRO for one of the binary gates, say AND gate or OR gate. And then after you've done that by hand, then pull out your code for the assignment and actually print out, use Python to print out the MRO, the dunder MRO attribute, and verify that it is the same as the one that you derived by hand.